Hello, Tim's Tips here. I'm going to talk to you about high power mobile applications using available battery technology, all the inverters and electrical charging systems available in the industry. First, a little background about me. I have a Bachelor of Science from Electrical Engineering from Penn State. I built an electric car about over 10 years ago with a 144 volt battery system, all lead batteries. So I definitely have a background in the older technologies. Moving up to the lithium systems, basically became a high voltage engineer. Worked with 50,000 volts in my career. I'm a systems engineer, so I like to see things integrated. To integrate all these systems into one whole operational system. An efficient house on wheels is my goal, minimizing the use of fossil fuels. First, the requirements. What did we really need out of this system? It's a whole house basically on wheels. I wanted to reduce cost and weight from some of the off-the-shelf systems, very, very heavy and costly. Increase the performance. The Tesla Model 3 battery has 20,000 watts, 20 kilowatts of output, but I limited that to half. If I were to try to put this on a 12 volt system, it would have been 800 amps at 12 volts. Just, you can't even do that. With this system, it limits it to 100 amps at 100 volts. So definitely more doable with the cabling I've created. Enable all electric camping. And I have a 3 kilowatt hot water faucet I want to do, as well as enabling an ultra efficient 220 volt mini split system and two 1.8 kilowatt induction cooktops. So I used to work in vendor management, and I researched the globe on vendors that could fulfill the needs of a high power system like this, high voltage, high power. So I determined that the Western versus Eastern was different philosophies. Western was more focused on safety, and Eastern was focused on performance and cost. So I looked at 48 volt systems. The Western systems only had 48 volt DC maximum, I think due to safety. They're sailing a ship of safety right into the ground by not allowing these higher voltage systems that are readily available in electric vehicles. So I chose the 96 volt system because a Tesla Model 3 battery was available, 20 kilowatt hours for about $2,200, a very cost-effective solution. This all gets back to first principles of design. Basically, you strip out everything that's not necessary and get what you need. Just disassemble it into elements and reassemble the ideas from the ground up. Reduce, reuse, recycle. So we're going to do that. Just keep the minimalistic system. And boldly question, where are the 96 volt DC systems? And the answer came from China. Answers also came from the EV industry, where they have up to 900 volt systems, very high efficiency, performance, and available BMS systems. Now I chose the Orion BMS2 because it is kind of in the hobbyist EV market, hobbyist or light industrial, because these things are being incorporated into electric cars, and they're very robust at this point. EV charging stations can be used with CAN, controller area network controlled chargers. This is a standard controller for all automobiles on the road, all modern autos on the road today. So I searched the Western Hemisphere, US, Canada, and Europe for 96 volt systems. There was Midnight Solar had a 96 volt solar charger, but they discontinued it, which is very disappointing that they wouldn't allow higher voltage systems for the sake of safety. They're sacrificing cost, performance, weight, and efficiency. It's a shame. So fear drives the engineering, which is not the way I want to go. It was very high cost, but on the good side, it was high reliability. The systems are like UL rated, high weight, typically very stoutly built, great documentation and support, and they were split phase aware. America has adopted a split phase system which to me is one of the more dangerous moves they ever did, whereas Europe and China operate on 220 volt systems, which there you go again, it's 220 volt AC. So why would they limit the DC to 48 volts? It's just a question I cannot answer. As you can see on the photo here, Schneider Electric sells a inverter charger. It's $1,400 for 4 kilowatts, but it's only 24 volts DC. Just to me, poor performance for a high cost. So I searched all the vendors, Western vendors, Victron, Ames, Schneider Electric. They have very high quality products. Unfortunately, the engineering behind them are deficient in my mind here. It's 2020, and we need to get into the higher voltage, lower current situations, whereas these things, they're drawing hundreds and hundreds of amps out of a battery that isn't meant to take it. So enter the Eastern Hemisphere, China and India. I searched them all on the web and found on AliExpress 96 volt, 110 volt inverters, or 220 volts, you had your choice, for $600. So less than half the cost of the Western, you might call it equivalent, for a lot less weight. Typically they weigh less than half the weight and half the cost. So that was what I chose for my mobile application. On the downside, of course, they have unknown reliability. They're not UL certified, and there's very little documentation. So you just kind of hook them up and experiment yourself, but so far it's worked out very well. So one of the safety features that I put in was extreme management, very controlled management of the battery with disconnects. If anything went wrong, this Orion BMS2 system would stop any charging or discharging. So it looks at the current, the voltages, all the cells. There's 25 different cells in the Tesla Model 3 battery that are monitored individually. If any one goes awry, goes astray, it shuts down automatically. It works easy on a Windows PC, or there's an Orion Connect internet monitoring system. And again, if anything goes wrong, it shuts down. It's pretty cautious. So let's look at the performance specs of the van build that I did. Two 1.8 kilowatt induction cooktops, 3 kilowatt hot water faucet, and a 6,000 BTU CR33 quiet climate control system. So I have no propane to heat or cool the van, and these things can all be running at the same time because I have a 20 kilowatt Tesla Model 3 battery behind it, two 6 kilowatt pure sine wave inverters, 1800 watts of solar, and a 6.6 kilowatt EV electric vehicle outlet or shore power charger. I can also charge from the alternator, and there's no generator required on this rig. And I've got a 50 amp cord reel so I can plug in to shore power at any time. So to further confuse you, here's a schematic of the entire van build. It took me 1,000 hours to create, design, and build this system into hardware. And if you have any questions, drop me a line, drop me questions, be happy to answer them. Very complex here, but on the user side, everything's protected here. You can see protection circuits all over the place. Very simple to operate, and gives you all the systems you need, just like a regular house. Here's the physical build of the control system for the van, and I'm going to get into more detail as days go on, and I invite you to subscribe to the channel and learn more about high current, high power mobile systems.